Today we'll start talking about the IMS, which is short for the IP Multimedia Subsystem. Just as a reminder for all of us, as we said, the IMS network is a new network we get or we integrate on the network we have, which means let's say you have a network like core, for example, and let's say this is the core network of the 4G. And what is core in 4G? It is the EPC, Evolved Packet Core. And in this Evolved Packet Core are the S gateway, P gateway, and MME. So here, if I have a network for the core or EPC only, anyone under the 4G coverage won't be able to make calls. And we said that the two options that we have are when the user wants to make a call, he does CS fallback or circuit switching fallback. And this way is less costly or money saving. And what does CS fallback mean? It means to let your user fall back to the 2G and 3G networks. And it is called CS fallback because on 2G and 3G networks, the user will use the circuit switching core, which is presented as MSC and media gateway. So he can do this call. And this is in case of mobile originating. But what about in mobile terminating? Same case exactly. Once a user is receiving a call and he is under the 4G coverage, this user will take a comment from the MME. Sorry, so take a command from MME. And then the eNode B will command the user to go and attach under the 2G and 3G sites, under the BTS or node B. So this is my first option. Now, what is my second option? It is to get a new network and set it up on my old network on the EPC or MME or S gateway or P gateway that I have. And this new network is called the IMS, and its abbreviation is the IP Multimedia Subsystem. The idea of a user making a call while him being under the 4G coverage and under 4G coverage means that, as we said, in the CS fallback, once this person wants to make a call, he will go to 2G and 3G. So with your mobile, if you're going to make a call with it and you are working with CS fallback, you will find your phone converting by itself to 2G or 3G if you are either receiving or making a call. But in case of IMS, the mobile will stay on 4G. And of course, this is much better than CS fallback. Because if you are opening a session, for example, like data session, and you are browsing or downloading or 4G and you receive the call, will this session cut off? In case of CS fallback, yes, it will cut off because you went down to 2G and 3G. But in case of IMS, no, the session will continue. So this is an advantage for IMS. And in this lecture, we'll be speaking about the role of IMS. So we are giving like an introduction about the IMS role, about the architecture of IMS on a high level, the structure of IMS, what are the network nodes in it, the signaling messages flow, and how they look like, or does it flow inside it. As all of this, we will mention in this lecture, right? Now, the IMS network, as I said, so you can let an A number call a B number, or let an A user talk to a B user. Of course, we said that he is under the 4G coverage. All right, so let's just type that here so you guys don't get lost. Right. So this is a 4G coverage. And this is also a 4G coverage. Right. Okay. Now, first thing that should happen is that these two users are attached to EPC. Right. So first, you're attached to the EPC, which is the evolved packet core. So they're attached to the EPC, which is the evolved packet core of the 4G networks. Second thing is that the two users as well have to be attached to the IMS network. So second attachment is the IMS network. All right. Okay. So you will register here twice. One time with the MME and another time with the EPC. So if you have the capability and your mobile can allow you to make voice over LTE calls, by the way, the solution altogether, since the other attaches on the EPC, then attaches on IMS and make a call only, make a call on 4G without falling back to 2G and 3G. This solution is called voice over LTE or VoLTE. I want you to differentiate between VoLTE and IMS, as VoLTE is voice over LTE, as you make a call on the LTE network without falling back to 2G and 3G by using the IMS network. So for this user to make a call to the other user, he has to be attached on the EPC and MME. And at the same time, he has to be attached on another node called the Cscf in the IMS network. So these are the basic requirements so you can make a call on IMS or voice over LTE call. Now, first thing we have is the Cscf, which is an abbreviation for call session control function. Now let's write that here. Call session control function. All right. So that's what the Cscf means. Let's put it here. All right. So Cscf is call session control function. All right. And this Cscf is the core or the heart of IMS. And this is like the MSC, as in the CS or circuit switching networks, as its main node is the MSC, which switches the user's connection, originates the calls, and controls the signaling messages, and even looks where this user or this subscriber is, and asks the HLR on how to reach this person. It almost does everything in the CS. And who looks like it in the IMS network? It is the Cscf, which is the call session control function. Up front, we will note that the Cscf is actually multiple nodes or has multiple functions. A function called proxy Cscf, and a function called interrogating Cscf, and a third function called the serving call session Cscf, or serving Cscf. I don't want you guys to bother yourself with these three for now, but now let's talk about the Cscf in general, which is the call session control function. We said that it is the core or heart of IMS, like the MSC is in the CS networks. And this means that these two users of the A number and B number will communicate with each other by Cscf. Now, how will Cscf do that? It will do that by the SIP protocol. Okay. As we explained SIP in the beginning, as SIP is the main core of the IMS, as any communication that happens in the IMS, and by communication, I mean that the network knows whether the Cscf or application servers or MTAS, all of these are nodes, so they can communicate or send to each other signaling messages as when a call happens, let's say from A number to B number. So there are a few call setup procedures or signaling messages that happen before the call initiates, and it happens by the A number sending these messages and passing through on the IMS network. And in the IMS network, the nodes will send the messages between themselves. And the type of these signaling messages are SIP, as the SIP protocol controls how these messages flow. So, for example, if Cscf will send to MTAS, now don't worry about the node functions, but in order for the Cscf to send to MTAS, there has to be a protocol to control the interface between the Cscf and MTAS. And this protocol is SIP protocol. And this SIP will work with us in the entire IMS network. And by the way, SIP is just an abbreviation for Session Initiation Protocol. So let's type it down here so you guys don't get lost. All right. So SIP Session Initiation Protocol. All right. So that's what SIP means. So SIP is the main protocol that we use during the communication of the nodes and each other. So the signaling messages in the IMS network will reach from one network node to another network node by the SIP protocol. Now, let's get back to the A number and B number. You will find that the A number will deliver the signaling messages as it decided to make a voice call and use the IMS network. So the A number will deliver its signaling messages by the Cscf. And then the Cscf will identify which user the A number wants to talk to. So it will take the identity of the B number from A number signaling messages. As when or during the A number makes the call setup, it states that it wants to talk to this B number with this specific identity and sends it to the Cscf. So here the Cscf will do two functions. It will know this B number, and after knowing this B number, it will relay the signaling message to the B number. So briefly, how will the call happen? By the A number sending call setup request messages to Cscf. And Cscf will then do two things. It will know who this B number is and where he is. And after that, it will relay the signaling messages to B number. So it can let these users open the channel together and let there be a connection that we can carry the user phone on. And what is user plane on? And what is user plane? User plane is the speech traffic between the two users. During the signaling setup or the previous steps that we mentioned, when the A number wants to call the B number, so it will send some signaling messages. And Cscf will then relay and identify who this B number is. A setup of media characteristics happen. And what is meant by the media characteristics? As we said, that the SIP message inside it are two things. And SIP message, just so no one gets confused, the A number will send the call setup procedures in signaling messages. And what are these signaling messages? It is the SIP signaling messages. And any SIP signaling message is composed of two things, which are the SIP header and SIP body. And SIP header has the control information, like my identity is X, for example, and my URI is X. And the B number identity is X as well, for example. So this is the SIP protocol. And in SIP body, another thing is available called the SDP, which is the Session Description Protocol. And we explained this in the SIP part. And the SDP function is to explain what are the media characteristics between these two users. And what do I mean by explain the media characteristics? So it will say, for example, the type of session that opened between the two users will be voice call. And please note that the SDP explains traffic, not signaling. So it explains the speech traffic that is between the two users, how it will look like. So the traffic itself is voice call or video call. It will state the codec that we will use is X, for example. So a negotiation will happen between the two users for the codec that will be used, or that will be used during the call. And the codec does something called sampling rate, something like PCM, which is pulse call moderation, that we learned before during in university. So I will cut my signal into how many samples per second, as each codec has its own way. So both users must agree on one codec. So this is the codec negotiation, and it happens in the SDP. And the function of SDP is to explain that the media characteristics and how they look like. Now, let's know how the IMS user gets detected by Cscf. Now, as the A number wants to call the B number, and it goes to the Cscf, and the function of Cscf is to know where this B number is. Initially, the Cscf has a registrar function or registrar server. If you remember in the SIP network, when we explained that we have proxy server and register server and location server. Now, the location, when we explained that we have, the location and registrar server are two internal functions available in the Cscf, which is the call session control function. So that's why when the A number sends, or when the A number sends to the Cscf, so the A number is stored in the Cscf, and it's probable that the B number is in the same Cscf as well. So that's why if the A number sent and asked to call this B number, and this B number is in the same Cscf. So what if the B number isn't available on this Cscf, but on another Cscf? Now in that case, it will go to reach the HSS, which is the home subscription server, and ask it where this B number is. So this means that the registrar server in the Cscf, that all users that are attached on the IMS are also attached on Cscf. And it's the exact same function of the MSC. So this means that the user, once he is provisioned VoLTE, he has to register himself on the Cscf and create a profile for himself on Cscf. And in this profile, some information is put, like his identity and his location. And location is the IP address. So since I said that this Cscf works as a registrar server and location server. So that means that I can store the identity of the user and the location of that same user. So we can say that the main basic function of Cscf is to know where the user is or where the B number is. And when it starts relaying the signaling messages, or in other words, routing the signaling messages between the users or switching of users, connecting, if you remember, as this was the function of MSC and the CS core. And the same function is with the Cscf, which routes the signaling messages between the users and each other. Let's make a simulation of it as if a call will happen. Let's say user 1 wants to talk to user 2, or the A number wants to talk to the B number. So first thing that will happen is that the two users will register on the EPC, Evolved Packet Core. And during the registration, they do the authentication, ciphering, and all the things that they do in the beginning. And authentication to make sure if this person is authorized to access the network or not, authorized to actually access the network. And after they finish, they register on the IMS network as they register on the Cscf. Like in the EPC, they register on the MME, as registration here means that this person has a profile on the Cscf. And now the second or the two are actually registered. Now the A number decided that he wants to call the B number. So A number will send signaling messages. He will state that he wants to make a request. So he can do a voice call to call the B number. And he put the identity of the B number, and the type of signaling messages is, as we read, SIP signal. As long as you are calling on the IMS, then this will be SIP signal. The Cscf now received the signaling messages from the A number. All right, now let's put that part in an easier mode. Now, as we can see here, it sent the call setup request, call setup request. Now, as you guys can see here, it set the call setup request. Now the call setup request is going from A number to the Cscf. And here we said that the Cscf will first see where the B number is. All right. Now let's define a few functions. Now Cscf will check B number user location, relaying signaling messages to the B number. So there's a first function and there's a second function. Let's type it down so you guys don't get lost. Now, first thing for the Cscf to do here, as we explained before, number one is Cscf will check B number user location. Let's put that a little bit wider. Right. Second function it will do is relaying signaling messages to the B number. All right. Let's just put the So that's almost what's going to happen here. Now, after that, the Cscf will relay the SIP sign to the B number. All right, so let's put that down here. Okay. See here now, Cscf will start relaying that part. Now it will relay SIP sign to, sorry for that, relay SIP sign to the number, right? And once I did the relaying of SIP signaling, so this is SIP signaling. So Cscf will do the relay SIP signaling to B number. And once I did relay of SIP signaling to B number, so I'm ready to open a media stream or connection between A number and B number. As you are ready for speech traffic and the talking phase is also ready. Now, how do I say that I'm ready between the SIP or actually ready? Because in the SIP signaling messages that I sent, there is a part of SDP or the session description protocol. And SDP describes how the media traffic will flow. What is the codec that we will use? What is the type of media itself? Is it voice or video? And all of this is described by SDP. And the traffic itself, so no one gets confused, the protocol itself that carries the user plane traffic will be the RTP protocol, and it might be UDP. So no one gets confused and says that the protocol that will carry the traffic is SDP. SDP is inside the SIP signaling message, but its function is just to describe how the media will flow. And this is the main function and its main function only. Now, any user, so he can connect on the IMS network, there has to be an IP connection. And to, let's say, to us in this example, what is the IP connection here, or by who is it done exactly? It is by the EPS, which is the Evolved Packet Switching System, by the 4G packet switching network. It can also be by an ADSL network or WLAN network, as all of these are IP connections, and by it, it can connect to the IMS. But let's focus on the VoLTE as we're explaining it. So we will focus on the EPS, which is the Evolved Packet Switching. So no one gets confused. EPC is the core of 4G, but EPS is the full 4G network. And EPS consists of EarTran, which is the radio access part, plus the EPC, who is the core part of 4G. Of course, the Cscf has other uses based on its own, based on the application service that I integrated in my network. And every operator has its own application server that they use. So based on the requirement of each mobile operator or each company, I decide what extra services the Cscf can do. And don't worry, we will discuss all of this in details up front. If we talk about the application servers that are available, you will find firstly in this example, all right? So it's the POC, POC. And POC is an abbreviation for push to talk over cellular. Now let's type that here so you guys can know it better. So it's push to talk over cellular. All right. Now, this POC is an application server that I use to actually drop or to do group calling functions, something like conference calls. Now, the second application is the presence server. The presence is like the HSS, which is the home subscription server. So I can say the presence server is the HSS. So let's type it down here. So again, this is like the HSS. Okay. Now, what is HSS? All right. So it is the HLR. And what is the HLR? It is the database of the 2G and 3G subscribers. And HSS is the database for the 4G subscribers. So any subscriber that will register himself on 4G networks will have a profile in the HSS. And its function is to store the information of the subscribers. And it's also used to know when the subscribers or where the subscribers' locations are. So as I told you, the A number wants to talk to the B number, but what if the B number is not on the same Cscf? So Cscf will get back to HSS and ask it where this B number is. So HSS will tell it that this person is on Cscf number 5, for example. So this is the second function for the HSS, and this is the second application server. I have a third application server that I did not write here, which is the SCC, which is the simultaneous call continuity or capacity. And it is used in the call setup so I can know if the B number now is on the 4G network or did it fall back on 2G and 3G. Now, any network in the world has 2G, 3G, and 4G. And if the network has 4G, we try to cover many places with 4G, but won't it be a possibility that the subscriber went to a place with no 4G coverage? So the user will drop to 2G and 3G. And if you drop to 2G and 3G, and in the same time I'm calling him, so the SCC server will tell me that this person is roaming on 2G or 3G or 4G. And by roaming, I mean what coverage is he under, or on which site, 2G site, 3G site, or 4G site. Now, the MMTEL application server, it is the biggest feature, or its biggest feature or function is that it supports in the voice call, whether the originating or terminating. And what does this mean? Now, the A number will make a call and will go to Cscf. Cscf will check the originating services assigned to this A number. Isn't it possible that the A number didn't pay his bill, so he's barred on all outgoing calls? And who will tell, let's say, who will tell it this information? It is the MMTEL application server, but this is in case of the originating. But what about terminating? What does B number have to do with it? The Cscf of B number, once it receives a request that this B number will receive a call, the Cscf will ask the MMTEL to tell it the terminating services of this B number. Isn't it possible that it may be barred so it can't receive any calls? So the MMTEL application server is used in providing the originating services during mobile originating calls, and also provides terminating services like MT calls or mobile terminating calls. And also MMTEL supports or has function interworking between CS and IMS. So if there is an IMS user that wants to talk to the CS user, and CS user means that this user is under 2G and 3G, so he's using CS voice call, and who supports this is the MMTEL.